Beloved students, feel welcome. Today's lesson is on differentiation, and the subtopic that we'll be looking at is on how to come up with a gradient function. I'm going to use a demonstration to come up with that gradient function. Then after all, we are going to generalize to other examples and other functions. Now consider this particular function, that is, consider the curve of function y equals to x squared. The gradient function of the curve is achieved from the first principle as follows. Now from there, I've provided a display of that particular curve, which is y, and on this side x. Now from this curve, I've tried to consider a straight line joining 2 points on the curve, that is P and Q. Now from these 2 points, I've tried to take a small change along the x-axis and another small change along the y-axis, and the following respective coordinates are actually obtained. Now from this particular curve, then we can actually clearly see that the gradient of the line PQ, of course, will be given by this particular relation, that is change in y, change in x. For this case, we are going to take change in y minus change in this y. So it will be x plus h squared minus x squared. And change in x, of course, is going to be x plus h minus x. Now from there, we will actually simplify this one by expanding here. We will simplify this one by expanding here. And if we expand here, we'll end up with x squared plus 2xh plus h squared minus x squared, then x plus h minus x. If we simplify this particular function, then we end up with 2xh plus h squared over h. Then you realize from there that this one can be simplified by cancelling out the common term to end up with 2x plus h. And from there, it's easy to see that as we bring this point Q closer to P, then we are saying as h goes to 0, then change in y, change in x reduces to 2. Now from there, the gradient function of the curve y equals to x squared is therefore 2x. Now this aspect can also be achieved as follows, that generally to get the gradient function from the first principle or a small change in x, we apply the following formula. So instead of us drawing that particular grid that I've already provided, that axis of x and y, then we can apply this short formula, which can easily and well understood and easy to follow. So we are going to say that change in y, change in x is equals to the limit as h goes to 0. Then you take the function, add a small change, minus the original function, divided by that small change that you've added. For example, consider this example 1. Consider this example 1, that y equals to 1. So the function given here is y equals to 1. Now, if we substitute this function on this particular formula, then realize that 1 is a constant, so it remains the same. So it is 1 minus the original function, which is 1, divided by the change, which gives you 0. So in short, it means that the gradient function of a constant is 0. In other words, differentiation of a constant is 0. Now, example 2, we can have this example 2 then, that a function y equals to x. So here, the function given is y equals to x. And recalling the formula and substituting, then we'll have x the function plus a small change minus x the function divided by h. X and x will cancel, and we remain with h over h, which is equals to 1. So the differential function, if you differentiate a function x, then you get 1. Example 3, we have another function here, which is y equals to x squared. And from this function, I can substitute it back to the formula here, and it will give me the function which is x plus a small h, but squared, minus the function itself over h. If we expand this and cancel out, then let the limit as h goes to 0, again we get it as 2x. Now we can also do the same by now generalizing from the three examples as follows, that generally the gradient function can be obtained as follows. Consider the examples provided above and generalize them to this table. We are going to have that the results from the above examples can be summed up in the following table. That is, if we have the gradient function and the function, then if the function is a constant, for example, y equals to 1, y equals to 2, then the gradient function is 0. If we have a function such as y equals to x, then the gradient function is 1. If we have a function y equals to x squared, then the gradient function is 2x. And if we have a function y equals to x cubed, then the gradient function is 3x. Now, from this table, we can see that there's a particular format that is coming up, and that particular format can be used to differentiate any function or to get the gradient function. And therefore, in general, the gradient function of y equals to xn is given by, you take n back here, multiply with the constant that is here, and then minus 1 from the power, which now goes to n x minus 1. So we've taken this power behind of x and then minus 1 from the power, and therefore we get what we call the gradient function. Therefore, generally, the gradient function of any function, let's say y equals to xn, is given by n taken back, and then you subtract 1 from the power. The gradient function is called the derived function. So whatever we get here, also we can call this one as the derived function. And the process of obtaining it, or that process of obtaining the gradient function, is now what we call differentiation. Now I want to provide some 3 examples to see how to differentiate different functions. The first example says, write down the gradient function of the function is y equals to 7x minus 8. And therefore, to get the gradient function, solution will be dy dx, which is change in y, change in x, is equals to 7, because we've said the differential of x is 1. So 1 times 7 is 7, and the differential of a constant is 0. So dy dx equals to 7. Secondly example, we are told to differentiate this particular function, and by so doing, realize that y is equals to x power 4 minus 3x squared plus 7. So the differential of x power 4, we take 4 back here, and we subtract 1 from the power. And by so doing, we have 4x cubed. Then on the second part, we take 2 back. Now it will be 3 times 2, which goes to 6. And then we subtract 1 from the power. This one reduces to 6. And therefore, the last part here, 7 is a constant. And as we said, the differential of a constant is 0. And therefore, dy dx reduces to 4x cubed minus 6x. Now, this one is referred to as the derived function. Example 3 says that find the derivative of y equals to 3x squared minus 7x plus 10. Now the same procedure will be followed, and if we do that one, realize that these 2 can be taken back to multiply with 3 to have 6. Then we subtract 1 from the power to remain with x. Now the differential of a function x is 1, and 1 times 7 is 7. Differential of a constant, we've said, is 0. And therefore, dy dx reduces to 6x minus 7. Now, I believe those few examples and also the demonstration on how to come up with a graded function has actually provided you with some basis information on how to differentiate functions. So I believe with more exercise and more practice, that concept will be well understood. Thank you for your time, and you can subscribe for more interesting lesson to follow. Enjoy your time and grateful. Thank you.